Next example, important example. Evaluate integration of z plus 4 divided by z square plus 2z plus 5 dz, where the given circle is mod z plus 1 minus I is equal to 2. This is the question. Okay. See the solution. F of z is this. Then circle equation is what? Mod z plus 1 minus I is equal to 0. Compare this equation with the standard equation of the circle, that is mod z minus z naught is equal to r. Okay, write this one in the form of this equation, mod z minus z naught is equal to r. Okay, z minus of, this can be written as mod z minus of minus 1 plus I. Since z, this is in the form of z minus z naught, that is minus 1 minus of minus 1, that is plus 1, minus into plus, that is minus I. Okay, that is equal to 2. Therefore this is the value of z naught and this is the value of r. Therefore center is minus 1 comma plus 1. Here radius is 2. This is x plus iy. This is in the form of x plus iy, where the real part is minus 1, imaginary part is plus 1. Okay. Therefore the center is what? Minus 1 comma plus 1. Okay. Here look at the graph. This is the center, minus 1, x-axis, real part minus 1 and y is plus 1. Okay. Therefore this is the center of the circle. Okay. First of all, we need to find the poles of the given function. Here denominator is what? Z square plus 2z plus 5. Therefore this can be solved by Sridhar's formula. Write this Sridhar's formula, minus b plus or minus root b square minus 4ac divided by 2a. Here b, a is 1, b is 2, c is 5. Substitute the values. Then solve. Minus 2 plus or minus 2 square is 4 minus 5, 4 into 5, 20 divided by 2. That is equal to what? Minus 2 plus or minus root 4 minus 20 minus 16 divided by 2. Root minus 16 is 4 into root minus 1, that is 4i. Minus 2 plus or minus 4i divided by 2. That is equal to, here 2 is common. Take 2 outside, into minus 1 plus or minus 2i divided by 2. 2 get cancelled. Remain minus 2 plus or minus 2i. Okay. Here the poles are what? Roots are minus 1 plus 2i, minus 1 minus 2i. These are the poles. Z is equal to minus 1 plus 2i and z is equal to minus 1 minus 2i are the poles. These are also in the form of x plus iy, x plus iy. Okay. Here the real part is minus 1, imaginary part is 2. Real part is minus 1, imaginary part is minus 2. Okay. Therefore f of z can be written as z plus 4. Here z minus into minus plus 1 and minus into plus minus 2i. Okay. Z minus z naught form, that is z plus 1 minus 2i. Here z minus into minus plus into minus plus 1 plus 2i. Okay. Is it right? F of z. Then see, these poles lies inside C or outside C. Here the center of the circle, we know the center of the circle is minus 1 comma plus 1. See here the first pole, minus 1 minus 2. Where it comes? Minus 1 plus 2. This is minus 1 plus 2 is here. Okay. Okay. This is the circle, therefore this comes inside the circle. Okay, this comes inside the circle. Then second pole, minus 1 minus 2. Minus 1 is there, minus 1 minus 2. Okay, this is the center of the circle. This is far from this center of the circle. Therefore this point lies outside C. Therefore No need to calculate the residue. Directly we write residue at z is equal to minus 1 minus 2i is equal to 0. Just we need to calculate the residue at z is equal to minus 1 plus 2i. Is it clear? The center is what? Minus 1 plus 1. But the first pole is what? Minus 1 minus 1 plus 2. This comes inside C. But second pole minus 1 minus 2 comes here. This is outside the circle. If we draw a circle, it comes outside C. Therefore, residue at this point is directly 0. No need to calculate the residue. Just we need to calculate this pole only. That is first pole. Minus 1 plus 2i. Write the poles, residue. Here, z is equal to minus 1 plus 2i is a pole of order 1. Okay, therefore, formula is residue at simple pole formula is residue at z is equal to a is equal to what? Limit z minus a into f of z as z tends to a. Here, residue at z is equal to minus 1 plus 2i is equal to what? Limit z minus of minus 1 plus 2i is equal to plus 1 minus 2i into f of z. Write the f of z. Here z plus 1 minus 2i, z plus 1 minus 2i cancels as z tends to minus 1 plus 2i. Okay, that is equal to what? Okay, substitute minus 1 plus 2i in place of z. Okay, as z tends to minus 1 plus 2i, that is minus 1 plus 2i plus 4 divided by minus 1 plus 2i plus 1 plus 2i, that is minus 1 plus 2i plus 4 divided by minus 1. Z is equal to what? Minus 1 plus 2i plus 1 plus 2i. Here 3, 4 minus 1, 3 plus 2i divided by 1 cancelled, 2i plus 2i, that is equal to 4i. This is the R1, that is R simply called R. This is residue at z is equal to minus 1 plus 2i. Then write the Cauchy's, substitute this R in the Cauchy's residue theorem. We get the answer. By Cauchy's residue theorem, we know that integration of f of z dz is equal to what? 2 pi I summation r. Here only one r is there. Therefore, 2 pi I into r. R is what? Into r. That is equal to 2 pi I into 2 plus 3 plus 2i divided by 4i. Simplify this one. I cancels 1, 2. That is equal to what? Pi by 2 into 3 plus 2i. This is the required answer, where f of z is equal to what? Z plus 4. Z plus 4 divided by z square plus 2z plus 5. Okay, thank you.